All right, let's jump right in. Imagine you've got a problem where every single guess, every attempt you make, is wildly expensive or takes forever. We're talking about things like designing a brand new material or creating a life-saving drug. You can't just try 1,000 different recipes to see what works. Today, we're going to look at a new AI that might just change all of that. It's called ZeroShotOpt. So to make this really hit home, picture a scientist trying to invent the perfect new medicine. They've only got enough budget for, say, 50 tries, and each attempt isn't quick. It takes weeks to run the tests. They're navigating this massive space of possibilities, different dosages, different compounds, with almost zero room for error. So you get the picture. The stakes are incredibly high.
Now, there's a technical name for this kind of challenge. It's called black box optimization. And the black box part is key. It means you can't see what's going on inside. You can put your inputs in, your recipe for the drug, and you see the output, how effective it was, but you have no idea why. You're basically working in the dark. And when every guess costs a fortune, you have to make each one count.
Okay, so what are people using right now to solve this? Well, the reigning champion is something called Bayesian optimization. And it is pretty amazing. It's really smart about how it makes its next guess, so it doesn't waste attempts. But, and you knew there was a but coming, right? Here's the big catch. For every single new problem, a human expert has to come in and meticulously, painstakingly hand-tune all of its settings. It just doesn't generalize. This is where the story gets really interesting. A team of researchers looked at this whole situation and said, you know what? This constant hand-tuning, that's the real bottleneck here. And their solution is pretty brilliant. What if you could build an AI that already knows how to optimize, an AI that learns the skill before you even give it a problem? And that's where this idea of a zero-shot optimizer comes in. So let's talk about the solution, ZeroShotOpt. The magic word here, the thing that changes everything, is pre-trained. Unlike Bayesian optimization, which is like a brilliant intern you have to train from scratch for every project, ZeroShotOpt is like hiring a seasoned expert who's already seen it all. It shows up on day one, ready to go. No hand-holding, no tuning. It's meant to be a genuine plug-and-play optimizer. And this quote from the researchers themselves just sums up their whole goal perfectly. They weren't just trying to make a slightly better optimizer. They were trying to completely change the game, right? To build something that takes the human tweaker out of the equation and makes this powerful technology available to, well, to everyone. So, how in the world do you teach an AI to become a master problem solver? Well, you send it to the most intense school imaginable. Let's break down how they actually trained this thing. First, you just have to appreciate the sheer scale of this. We are not talking about a couple hundred or even a few thousand examples. This model studied almost 20 million complete problem-solving sessions. Basically, it watched the best optimizers in the world solve millions of problems, learning from every single move, what worked, what didn't, to build this incredible intuition for how to solve problems in general. And the way they did it is so clever. They broke it down into 3 steps. Step 1, they built the classroom. They just generated millions and millions of diverse synthetic problems for the AI to learn from. Step 2, they hired the teachers. And these aren't just any teachers. They're 12 different expert Bayesian optimization methods. And they had these experts solve every single one of those millions of problems. And then step 3, train the student. The AI model, ZeroShotOpt, just sat there and studied all of those solutions, looking for the universal patterns, the core strategies that work no matter what the problem looks like. And this student is, a bit of a genius. It's a 200 million parameter transformer model. And if that word transformer rings a bell, it absolutely should. It's the exact same AI architecture that powers the big large language models we've all been hearing about. But instead of learning to predict the next word in a sentence, this model learned to predict the next best guess in an optimization problem. It learned the language of finding solutions. Okay, that training regimen sounds pretty epic, but does it actually work? I mean, that's the real question, isn't it? Can this generalist, with zero prep, go head-to-head with the hand-tuned specialists on a problem it's never, ever seen before? Let's check the report card. All right, so this is the moment of truth. They took ZeroShotOpt and threw it at completely new sets of problems, standard benchmarks it had never encountered in its training. This is the definition of a zero-shot test. It's like a boxer who's only ever trained against southpaws suddenly being put in the ring with an orthodox fighter. Does the training actually translate? And the results, frankly, they're pretty mind-blowing. What you're seeing here is how it performed on these totally unfamiliar test sets.
And just look at that top line. ZeroShotOpt didn't just hang with the experts, it consistently came out on top, ranked #1. This is without any of that special tuning the others got. But it's not just about getting the best answer. It's also about how fast you get there. And on that front, the difference is just staggering. This bar chart shows you the time it takes to make just one evaluation on a pretty complex problem. The best traditional method takes almost 90 seconds. 90? ZeroShotOpt goes in about 5.5. That's not just a little faster, that's a whole different ballgame. For a research lab, that can mean the difference between a project taking months versus years. But wait, there's more. So its main superpower is being this awesome general problem solver, right? But the researchers also wanted to see if it could specialize. And it turns out, yes. They took the model, gave it a little bit of extra training on a very specific type of problem, and boom, it became a top-performing specialist in that area too. So you kind of get the best of both worlds.
So when you step back and look at all this, it's pretty clear this isn't just about a faster algorithm. This really could be a fundamental shift in how we attack these really hard optimization problems across all of science and engineering. The researchers really see this as a foundational model, kind of like GPT is for language. It's a base layer that other, more specialized tools can be built on top of. Think about it. You could fine-tune versions for designing new batteries or discovering new drugs. You could even feed it more info to give it context. And of course, the big one, just like with language models, the thinking is that as these models get bigger and are trained on even more data, they're just going to get better and better. And all of this kind of leaves us with one big, fascinating question. We've created an AI that hasn't just memorized solutions, but has actually learned the art of problem solving itself. It's not just running through a checklist, it's using a flexible, generalized strategy. So as this technology gets more powerful, the question stops being, what can it solve? And starts becoming, okay, what are the biggest, hardest, most important problems we should point this thing at next?